Hey everybody, in this video we want to solve problem 199, number of 1 bit on LeetCode on May 26, 2022. So the problem is we are given an unsigned integer n and the task is to return number of 1 bits in that number. For example, as you can see, given this number, we should count number of 1 bits. So in some programming languages such as Java, as it is mentioned here, unsigned integers are not implemented. But in most of the programming languages, such as C++, C Sharp, or C, uh, unsigned integers are implemented. So both integers and unsigned integers consist of 4 bytes or 32 bits. And the only difference is that in an integer, the first byte represents the sign of the value. So if it is 0, it represents a positive, and if it is 1, it represents a negative number. But unlike integer, unsigned integers use the first byte to contain value as well. So the scope of the integer is between a negative and some positive value, but the scope of the unsigned integer is always greater than or equal to 0. And the maximum positive value in an unsigned integer is larger than the maximum positive value in an integer. So in order to solve this problem, we're going to see two different ways today. So first one is a bitwise. So let's say given an n, we know that it has 32 bits. And let's focus on the first bit for now. Let's ignore the first 31 bits and then just focus on the first one. If we can implement a way to check if this specific bit in n is 1 or 0, then we count it and then we store somewhere as a count starting 0. And then if this is 1, so we just increase that count. And then we, using a bitwise shift, we just shift the whole number to the right by 1 bit, and automatically the left bit will be filled with 0. And then this 31 bits will be shifted to the right. And since we know n itself consists of 32 bits, and if we repeat this procedure for 32 times, we can eventually count all 1 bits in the number. And in order to check or extract the first bit from a number, we can use a bitwise AND with value n, with n and 1, because 1 is an integer, but in a bit representation, if I want to show them in bits, we know that it consists of 31 bits and 1 1. And using this AND logic here, we are somehow masking or dropping everything before the first bit in n. We are forcing them everything, setting them to be 0, and then we just check if the rightmost bit is 0 or 1. So let's go to the implementation. So this store count as 0, and then 32 times 32. If n and 1 equal 1, and you're adding that to the 1. And every time we're doing that, you're shifting n by 1 bit. So n equals n shifting it to the right, and then return CNT. So this is one way to implement that. Let me use the other one, the number here. This is one way to implement that. The easier one-line solution for this problem in Python without importing any library is to use the bean function. So in Python, by default, bean and hex functions are implemented, which they're taking an integer as an input. So like n and hex as well. So let me print them. Return none for now. So this is, as you can see, these two are strings, and the binary is just returning a string starting with 0b and a bunch of zeros and ones in character format, not in a number. And a hex function is returning a string representing the number in base 16 starting with 0x and then a bunch of characters from 0 to f. So here we don't want to use hex, but instead in bin we could say, we know that the first two characters are 0 and b, so we could say we want to take out anything after 2. We are dropping the first two characters, and we want to count number of 1 characters in that specific string, because we know that the binary representation of n is in a string like 0b, and then bunch of zeros and ones. But since we know that the first two characters themselves are not 1, so one of them is 0 and one of them is b, so it is not important that we drop them, so we can keep them as well, and simply just return this bin and then count on that, and that would be everything. So if I submit that, so we can simply solve this problem by using a one line. This is a one-line solution for this problem on today's challenge. So hope you liked it, and that was everything for today.